What if the solution to Earth's energy crisis isn't in our backyards, but millions of miles away in the cold, dark void of space? For decades, humanity has scoured the planet for sustainable energy sources, from wind farms to solar panels. But what if the answer lies far beyond our atmosphere? Today, we're exploring a revolutionary idea that could change everything: space-based energy systems. This isn't science fiction. It's a tangible, futuristic technology that could power our planet with limitless, clean energy. From solar power satellites beaming energy back to Earth to breakthroughs in wireless transmission, this concept promises to solve one of humanity's greatest challenges. But how does it work? What are the hurdles, and why could this be the key to a sustainable future? In this video, we'll unpack the science, the potential, and the groundbreaking innovations that could make this vision a reality. Are you ready to take a journey into the cosmos to discover how the stars might light up our world? Let's get started. The idea of harnessing energy from space might sound like science fiction, but its roots stretch back further than you might think. In the 1960s, at the height of the space race, a groundbreaking concept emerged from the mind of Dr. Peter Glaser, a visionary scientist who imagined a future where solar power could be collected in space and beamed back to Earth. Unlike solar panels on our planet, which are limited by weather, nighttime, and atmospheric interference, Glaser's concept of solar power satellites promised an uninterrupted, constant stream of energy. This wasn't just a fleeting idea. It was a bold vision that laid the foundation for an entirely new way of thinking about renewable energy. At the time, the technology needed to bring this vision to life was still in its infancy. The concept required massive satellites equipped with solar arrays, capable of converting sunlight into microwave or laser energy and transmitting it across the vastness of space to receiving stations on Earth. It was an ambitious plan, and while the theoretical groundwork was solid, the practical challenges were immense. Engineers and scientists faced hurdles like the cost of launching materials into orbit, the efficiency of energy conversion, and the precision needed to beam power safely over such distances. Yet, despite these obstacles, the idea sparked a wave of curiosity and innovation that continues to this day. Over the decades, the concept of space-based energy has evolved, shaped by advancements in technology and a growing urgency to find sustainable energy solutions. What began as a theoretical proposal has now become a tangible goal, with modern projects exploring everything from smaller, more cost-effective satellites to breakthroughs in wireless energy transmission. Looking back at its origins helps us appreciate not just how far we've come, but also the ingenuity and perseverance that have driven this field forward. As we continue to push the boundaries of what's possible, the dream of space-based energy remains a powerful reminder of humanity's potential to think bigger and reach further than ever before. At the heart of space-based solar power lies a groundbreaking concept that flips traditional energy generation on its head. Instead of relying on solar panels fixed to the Earth's surface, this technology places them in orbit where they can harness the sun's energy uninterrupted. Up there, away from the atmosphere, clouds, and the cycle of day and night, solar panels can operate at peak efficiency around the clock. The sunlight in space is more intense and consistent, meaning these panels can generate far more electricity than their terrestrial counterparts. Once the solar panels capture the sunlight, they convert it into electricity using advanced high-efficiency solar cells. These aren't your typical rooftop panels. They're specifically designed for the harsh conditions of space, built to withstand extreme temperatures and radiation. The electricity generated is then transformed into a form that can be transmitted wirelessly, a process that might sound like science fiction but is rooted in well-established science. Here's where the real magic happens. The energy is transmitted to Earth using either microwave or laser technology. Microwaves are particularly effective because they can travel through the atmosphere with minimal loss, even in cloudy or stormy weather. On the ground, large receiving stations, often called rectennas, capture this energy and convert it back into electricity that can be fed into the power grid. One of the most compelling advantages of space-based solar power is its ability to provide a continuous energy supply. Unlike ground-based solar systems, which are limited by daylight hours and weather conditions, space-based systems can generate power 24/7. This could revolutionize how we think about renewable energy, offering a reliable and sustainable solution to meet our growing energy demands. But how does this technology overcome the challenges of terrestrial solar power? For starters, it bypasses the inefficiencies caused by the Earth's atmosphere, which absorbs and scatters sunlight before it reaches the ground. Additionally, space-based systems aren't affected by seasonal changes or geographic limitations, making them a truly universal energy source. Imagine a world where energy is no longer constrained by location or time of day, where every corner of the planet has access to clean, reliable power. That's the promise of space-based solar power. The road to making this technology mainstream isn't without hurdles, but the potential rewards are immense. By tapping into the limitless energy of the sun from space, we could take a giant leap toward a sustainable future, redefining what's possible in the realm of clean energy. Imagine a world where energy is available around the clock, no matter where you are. Space-based energy systems promise exactly that. Unlike traditional solar panels on Earth, which are at the mercy of cloudy skies and nighttime, these systems operate in orbit, basking in constant sunlight. This means they can generate power without interruption, providing a steady and reliable energy source that could revolutionize how we power our planet. One of the most striking benefits is their minimal environmental footprint. While fossil fuels release harmful emissions that accelerate climate change, space-based energy systems produce clean power without burning any resources. By harnessing solar energy directly from space, we could significantly cut down on greenhouse gas emissions, offering a practical solution to one of the most pressing challenges of our time. Plus, since these systems don't require vast tracts of land or disrupt ecosystems, they're a far more sustainable option compared to many traditional energy sources. Another game-changing advantage is energy independence. Countries that currently rely on imported fuels could develop their own space-based systems, reducing their dependence on global markets and geopolitical tensions. This could create a more stable energy landscape worldwide, where every nation has access to clean, abundant power. It's not just about technology, it's about reshaping the way we think about energy security and sustainability for generations to come. Space-based energy systems hold incredible promise, but let's not gloss over the challenges because they're as big as the potential itself. First, there's the elephant in the room: cost. Launching equipment into space is astronomically expensive, literally. Building, deploying, and maintaining satellites or solar arrays in orbit requires cutting-edge technology, and that doesn't come cheap. Even with advancements in reusable rockets, the initial investment alone could run into the billions, if not trillions, of dollars. And let's not forget the ongoing expenses for maintenance, repairs, and upgrades. Who foots the bill? Governments, private companies, a mix of both? These are questions that still need answers. Then there's the technology barrier. Transmitting energy wirelessly from space to Earth sounds like something out of science fiction, but it's a very real challenge. The process, often called power beaming, involves converting solar energy into microwaves or lasers and sending it through the atmosphere to receiving stations on the ground. Sounds simple enough, but in practice it's incredibly complex. The transmission needs to be precise, efficient, and safe. Imagine the consequences of a misaligned beam. It could have catastrophic effects. Plus, we still need to optimize the technology to minimize energy loss during transmission, which is no small feat. Another hurdle is logistics. Building and launching these systems requires international cooperation on an unprecedented scale. Think about it, space is a shared resource, and something as ambitious as a global energy network would need agreements on everything from orbital slots to safety standards. And what happens if something goes wrong? Who's responsible for debris or malfunctions? These are critical questions that need clear answers before we can move forward. On top of all this, there's the environmental impact to consider. While space-based energy could reduce our reliance on fossil fuels, launching rockets still produces significant carbon emissions. Plus, the sheer scale of these projects could lead to increased space debris, which is already a growing problem. Balancing the long-term benefits with the short-term environmental costs is a delicate act. These challenges might seem overwhelming, but they're not insurmountable. History shows us that human ingenuity often rises to meet even the most daunting problems. The question isn't if we can overcome these barriers, it's how. With continued innovation, collaboration, and investment, the dream of powering Earth from space could one day become a reality. But it's going to take time, effort, and a whole lot of problem solving. Imagine a world where the power you use every day doesn't come from cables or grids, but from the sky above. This isn't science fiction anymore. It's the direct result of groundbreaking advancements in wireless energy transmission, a crucial element of space-based energy systems. At the heart of this revolution are technologies that sound like they're straight out of a futuristic movie, yet they're becoming a reality faster than many of us might think. One of the most promising innovations is the use of directed microwave beams. Picture this: solar panels in space collect sunlight, convert it into energy, and then send that energy down to Earth as a focused microwave beam. This beam is precisely aimed at receiving stations on the ground, where it's converted back into electricity. The precision required for this process is staggering, but recent breakthroughs have made it not only possible but safe and efficient. Advanced systems now ensure that these beams stay on target, even over vast distances, reducing risks and maximizing energy delivery. Another game changer is laser technology. Lasers are being explored as a way to transmit energy with incredible accuracy. Unlike microwaves, which disperse over long distances, lasers can maintain a tight beam, making them ideal for targeted energy transfer. Imagine a laser beam carrying energy from a satellite to a remote village or an off-grid community, providing power where traditional infrastructure can't reach. While challenges like atmospheric interference still exist, researchers are making strides in overcoming these hurdles, bringing us closer to a world where energy can be delivered with pinpoint precision. Of course, none of this would be possible without advanced receivers. These devices are the unsung heroes of wireless energy transmission, designed to capture and convert the incoming energy into usable electricity. Modern receivers are becoming more efficient, smaller, and cheaper, making them practical for widespread use. Some prototypes are even being tested for integration into everyday objects like rooftops or vehicles, turning them into energy hubs without the need for cables or plugs. Together, these breakthroughs are transforming how we think about energy. They're not just incremental improvements, they're foundational shifts that are paving the way for a future where energy is beamed directly to our homes, businesses, and communities. And as these technologies continue to evolve, the dream of a world powered by space-based energy systems is inching closer to reality. Japan has long been at the forefront of innovation, and their work in space-based energy is no exception. The Space Solar Power Systems, or SSPS project, is a shining example of how far this technology has come. It all began with early experiments in the 2000s, where Japanese researchers explored the concept of capturing solar energy in space and beaming it down to Earth. These initial studies laid the groundwork for what has now become one of the most ambitious energy projects in the world. Fast forward to today, and Japan's SSPS initiative is aiming for something truly groundbreaking: a full-scale solar power satellite by 2030. This isn't just about generating energy, it's about redefining how we think about power sources entirely. The satellite will use massive solar arrays to collect sunlight, which is then converted into microwaves or lasers and transmitted to receiving stations on Earth. These stations would convert the energy back into electricity, providing a clean, virtually limitless power supply. What makes Japan's approach so remarkable is the level of international collaboration involved. They've partnered with countries like the United States and organizations such as the European Space Agency to pool resources, share expertise, and accelerate development. This global effort underscores the importance of teamwork in tackling challenges as vast and complex as space-based energy. Governments and private sectors alike are recognizing the potential here, pouring funding and support into making these futuristic systems a reality. Japan's progress also highlights the critical role government backing plays in advancing cutting-edge technologies. From funding research to creating regulatory frameworks, the Japanese government has been instrumental in driving the SSPS project forward. Their long-term vision and commitment serve as a model for other nations looking to invest in sustainable energy solutions. By 2030, Japan aims not only to launch their satellite but to inspire a new era of energy innovation worldwide. This case study is a testament to what's possible when ambition, collaboration, and technology come together. The surge of interest in space-based energy systems wouldn't be possible without the transformative contributions of private companies. Visionary organizations like SpaceX, Blue Origin, and others have stepped into the arena, reshaping what's achievable in the cosmos. These companies aren't just participants in this technological revolution. They're the driving force behind it, pushing boundaries and redefining the possibilities of space exploration. Their involvement has introduced a new era of innovation, where the dreams of harnessing energy from space are becoming tangible realities. One of the most significant impacts of private companies is their ability to drastically reduce costs. Traditional space missions were often hindered by exorbitant expenses, but companies like SpaceX have pioneered reusable rocket technology, slashing the price of launching payloads into orbit. This shift has made it economically feasible to consider ambitious projects, such as deploying solar power satellites or constructing energy harvesting platforms in space. What once seemed like a distant fantasy is now within reach, thanks to these cost-saving advancements. But it's not just about affordability. These companies are also accelerating the pace of innovation. With their agile, risk-taking approach, they're able to test new ideas and iterate rapidly, something that's often challenging for government-led programs. For example, Blue Origin's focus on developing efficient space infrastructure and SpaceX's advancements in satellite technology are laying the groundwork for the infrastructure needed to support space-based energy systems. Their efforts are creating a ripple effect, inspiring other players to enter the field and contribute to the collective progress. Perhaps one of the most exciting aspects of private sector involvement is their ability to make space more accessible. By democratizing access to space, these companies are opening doors for smaller organizations and startups to participate in the development of space-based energy solutions. This collaborative ecosystem is fostering a diverse range of ideas and technologies, ensuring that the future of energy isn't limited to a single vision, but is instead a mosaic of innovative approaches. As we look ahead, it's clear that private companies are not just accelerating the timeline for space-based energy systems, they're also bringing them closer to commercialization. Their ability to merge cutting-edge technology with business acumen is creating a pathway for these systems to become viable, scalable, and ultimately part of our everyday lives. The role they play is pivotal, and their continued efforts will be essential in turning this futuristic vision into a practical reality. When we think about the environmental challenges we face today, the need for clean, sustainable energy solutions becomes undeniable. Space-based energy systems offer a groundbreaking alternative that could address these issues in ways we've never seen before. Unlike traditional fossil fuels, which release harmful emissions into the atmosphere, space-based energy generates power without contributing to air pollution or greenhouse gases. Imagine a world where our energy needs are met without compromising the air we breathe or the climate we depend on. This technology could make that vision a reality. Another key advantage lies in its minimal land use. Terrestrial renewable energy sources like solar farms and wind turbines require vast areas of land, which can disrupt ecosystems and displace wildlife. Space-based systems, on the other hand, operate entirely above Earth, eliminating the need for large-scale land development. This means we can preserve natural habitats and protect biodiversity while still meeting our energy demand. It's a win-win for both humanity and the planet. The potential to reduce our carbon footprint is immense. By shifting to space-based energy, we could significantly decrease our reliance on fossil fuels, cutting down on the emissions responsible for global warming. Over time, this could lead to a dramatic reduction in climate change impacts, from extreme weather events to rising sea levels. The benefits extend beyond just cleaner air. It's about safeguarding the future of our planet for generations to come. What's particularly exciting is how this technology aligns with the broader goals of sustainability. It's not just about producing energy, it's about doing so in a way that respects the delicate balance of our environment. Space-based energy could play a pivotal role in creating a greener, more sustainable future, one where we harness the power of the cosmos to protect life on Earth. The possibilities are as vast as space itself, and the journey toward a cleaner planet has never looked more promising. The economic ripple effects of space-based energy are nothing short of transformative. Imagine a world where energy is no longer a scarce resource but an abundant, affordable utility. By harnessing solar power directly from space, we could see a dramatic reduction in energy costs, unlocking financial savings for households, businesses, and governments alike. This shift wouldn't just save money, it could fundamentally reshape global markets. One of the most exciting prospects is the emergence of entirely new industries. Think about the infrastructure needed to build, launch, and maintain space-based solar arrays. Entire supply chains would spring up, from advanced manufacturing to space logistics, creating millions of jobs in engineering, construction, and aerospace. And it's not just about the hardware. Software developers, data analysts, and even space tourism could see unprecedented growth, turning this technology into an economic powerhouse. But the impact goes beyond job creation. Space-based energy has the potential to disrupt traditional energy markets, reducing dependence on fossil fuels and the geopolitical tensions that often come with them. Countries that currently rely on importing energy could become self-sufficient, while those with limited access to electricity could leapfrog into a renewable energy future. This technology could democratize energy access, bridging the gap between developed and developing nations. What's more, the affordability of clean energy from space could accelerate innovation across other sectors. Industries like transportation, agriculture, and manufacturing could see their costs plummet, freeing up resources for growth and development. the economic benefits would be felt globally, creating a more equitable and sustainable energy landscape. This isn't just about powering homes or businesses, it's about powering progress. The potential for space-based energy to transform economies is immense, offering a future where energy is not only clean but also universally accessible. The question isn't whether this technology will change the world, it's how quickly we can make it happen. When it comes to space-based energy systems, there's one thing that's crystal clear. This isn't a venture any single nation can tackle alone. Think about it, the sun doesn't shine exclusively on one country, and the technology needed to harness its power from space will require a unified global effort. That's where international collaboration comes into play. Organizations like the United Nations, the International Telecommunication Union, and even specialized space agencies from multiple countries are already laying the groundwork for cooperation. These groups are essential in creating frameworks that ensure fair access, shared benefits, and the responsible use of space resources. But collaboration isn't just about sharing the rewards, it's also about addressing the challenges. Take space debris, for example. As more satellites and energy systems are launched into orbit, the risk of collisions and environmental damage grows. International treaties and policies will play a critical role in managing this issue, ensuring that space remains a safe and sustainable environment for everyone. Another key area is energy sharing. How do we distribute the power generated in space equitably across nations? This isn't just a technical question but a diplomatic one, requiring agreements that balance the needs of developed and developing countries alike. Regulatory frameworks will also be crucial. Right now, space is often described as the Wild West, with limited rules governing its use. For space-based energy systems to succeed, we'll need clear, enforceable policies that promote innovation while preventing exploitation or conflict. Think of it as building a global infrastructure, not just in space but here on Earth, through partnerships and agreements that bring nations together. The stakes are high, but so are the potential rewards. By working together, we can ensure that space-based energy becomes a source of unity and progress rather than division. As we look toward the vast potential of space-based energy systems, there's an invisible but growing threat that could jeopardize the entire endeavor: space debris. Picture this: thousands of defunct satellites, spent rocket stages, and fragments from past collisions whizzing around Earth at incredible speeds. This ever-growing cloud of debris isn't just an abstract concern. It's a real and pressing danger to the satellites and infrastructure we'll need to harness energy from space. The challenge is twofold. First, space debris increases the risk of collisions, which could damage or destroy crucial satellites. Even a tiny piece of debris, traveling at several kilometers per second, can cause catastrophic damage. Second, as more satellites are launched to support space-based energy systems, the risk of creating even more debris grows. It's a vicious cycle that could render key orbits unusable if left unchecked. Thankfully, scientists and engineers are already working on solutions. One promising approach is active debris removal, developing technologies to capture and deorbit defunct satellites and other large pieces of debris. Think of it as a cosmic cleanup mission where robotic arms, nets, or grappling systems are used to safely dispose of space junk. Another key innovation is collision avoidance systems, which use advanced sensors and algorithms to predict potential impacts and adjust satellite trajectories in real time. But tackling this issue requires more than just technological breakthroughs. International cooperation is essential. Space is a shared resource, and managing debris effectively will demand collaboration among nations, private companies, and space agencies. This includes establishing stricter guidelines for satellite launches and end-of-life disposal to prevent the problem from worsening. The stakes are high. Without addressing the space debris challenge, the dream of space-based energy could remain just that, a dream. By investing in debris removal, improving collision avoidance, and fostering global cooperation, we can ensure that the pathways to space remain open and safe. This isn't just about protecting satellites, it's about securing a sustainable energy future for generations to come. Picture this, the year 2050. Cities hum with life, not from fossil fuels or sprawling power plants, but from an invisible network of energy beamed down from space. High above the Earth, satellites equipped with advanced solar arrays capture the sun's rays unfiltered by our atmosphere and convert them into immense power. This energy is then transmitted wirelessly to receiving stations on the ground, seamlessly integrating into the grid to power homes, factories, and even electric vehicles. It's not science fiction, it's a future we could very well be heading toward. The impact of such a system would be profound. Imagine a world where energy scarcity is a thing of the past. Remote villages in developing nations, previously cut off from reliable electricity, could suddenly have access to clean, abundant power. Industries would no longer be shackled by the limitations of traditional energy sources, unlocking new possibilities for innovation and growth. And with energy beamed from space, the environmental toll of mining, drilling, and burning fossil fuels could finally be left behind. But it's not just about utility, it's about transformation. Cities designed around space-based energy systems could look radically different. Skyscrapers might be constructed with built-in receivers, turning entire buildings into self-sustaining power hubs. Electric vehicles could charge wirelessly as they move, eliminating the need for charging stations. Even rural areas could become thriving hubs of activity, no longer held back by their distance from energy infrastructure. Of course, this vision isn't without its challenges. The technology to make this a reality is still in its infancy, and questions about cost, safety, and international cooperation remain. But the potential is undeniable. A world powered by space-based energy isn't just a dream, it's a glimpse into what could be possible when we look beyond the confines of our planet for solutions. Space-based energy systems sound like something straight out of a science fiction movie, but they're very real, and they have the potential to revolutionize how we power our world. But here's the thing, for this futuristic technology to take off, it needs more than just advanced engineering and cutting-edge science. It needs us. Public perception and awareness are critical factors in determining whether these systems will gain the support and investment necessary to become a reality. So, what do people really think about the idea of beaming energy down from space? Right now, opinions are mixed. Some see it as a game-changing solution to our energy crisis, while others have reservations ranging from concerns about safety to skepticism about feasibility. Part of the challenge is that space-based energy is still a relatively new concept for many. It's not yet part of the mainstream conversation, and that lack of familiarity can lead to misunderstandings or even fear. Take the myth that space-based energy is dangerous because of the microwave or laser transmissions used to send power to Earth. While it's true that these technologies sound intimidating, the reality is that they're designed with rigorous safety standards. The energy beams are carefully calibrated to be harmless to people, animals, and the environment. Addressing misconceptions like this is key to building trust and showing that this isn't just a bold idea, it's a responsible one. Another important step is highlighting the benefits in a way that resonates with everyday people. Think about it, space-based energy could provide a nearly limitless supply of clean power, reducing our reliance on fossil fuels and helping to combat climate change. It could also bring electricity to remote areas where traditional energy infrastructure is difficult or impossible to build. These aren't just abstract advantages, they're tangible improvements that could touch lives in meaningful ways. But raising awareness isn't just about dispelling myths and touting benefits. It's also about listening. People naturally have questions and concerns, and addressing them openly and honestly is essential. How will this technology impact energy costs? What happens if something goes wrong? By engaging with these questions and providing clear, transparent answers, we can bridge the gap between curiosity and confidence. Ultimately, space-based energy isn't just a technical challenge, it's a human one. Building public support means creating a dialogue, fostering understanding, and showing how this technology aligns with the values and needs of people around the world. When we get that right, the possibilities are electrifying. When we think about renewable energy, solar panels, wind turbines, and hydropower often come to mind as the go-to solutions. But how does space-based energy stack up against these established technologies? Let's break it down. Solar energy, for example, is highly effective during daylight hours but struggles with inconsistent weather and nighttime limitations. Wind power offers a strong alternative, yet it's heavily dependent on location and wind patterns. Hydropower, while reliable in areas with ample water flow, can disrupt ecosystems and requires specific geographic conditions. Space-based energy, on the other hand, operates outside these constraints. By harnessing solar power directly in orbit, it avoids atmospheric interference and provides a near-constant energy supply, regardless of time or weather. This gives it a significant edge in consistency and reliability. However, it's not without its challenges. The initial costs of launching and maintaining these systems are substantial, and the technology is still in its early stages compared to the more mature infrastructure of traditional renewables. What makes space-based energy truly unique is its potential to complement rather than replace existing systems. While solar and wind will continue to play vital roles, space-based energy could fill in the gaps, offering a steady baseline power source that reduces the need for energy storage solutions. It's not about competing with other renewables, but creating a more robust and diversified energy ecosystem. By combining the strengths of each, we can move closer to a future where clean, sustainable energy is accessible to all. As we venture into the realm of space-based energy systems, one of the most intriguing challenges isn't just technological, it's legal. Who owns the sunlight beamed down from space? Who has the right to harness it? These aren't just hypothetical questions. They're foundational issues that will shape the future of this groundbreaking technology. Right now, space law is a patchwork of treaties and agreements, many of which were drafted decades ago, long before solar panels in orbit were even a possibility. The Outer Space Treaty of 1967, for instance, declares that space is the province of all mankind. But what does that mean when private companies or nations start collecting energy from it? Ownership becomes even murkier when you consider the infrastructure. If a company launches a satellite to capture solar energy, does it own the power it generates, or does that energy belong to the international community? And what happens if two entities claim the same space or resources? Dispute resolution in space is far from straightforward. There's no galactic court to settle conflicts, and existing legal frameworks on Earth weren't designed to handle issues like orbital real estate or energy rights. This legal ambiguity could either slow down progress or open the door to innovation. On one hand, unclear regulations might deter investment, as companies seek stability before committing vast resources to space-based projects. On the other hand, the flexibility of current laws could encourage creative solutions and international collaboration. Imagine a future where nations and private enterprises work together under shared agreements, pooling resources to build and maintain these systems for the benefit of everyone. But getting there won't be easy. Governments, organizations, and legal experts will need to come together to craft new frameworks that balance innovation with fairness. The stakes are high. If we get this right, space-based energy could revolutionize how we power our planet. If we get it wrong, it could lead to conflicts that extend far beyond Earth's atmosphere. The next few years will be pivotal in determining whether this technology becomes a source of unity or division. The advancements in space-based energy systems wouldn't be possible without a suite of cutting-edge technologies working in harmony. At the forefront are advanced materials that are revolutionizing how we build and operate these systems. Lightweight, ultra-efficient solar panels, for instance, are designed to maximize energy capture while minimizing the weight and cost of launching them into orbit. These panels use materials like gallium arsenide, which outperform traditional silicon in space, where efficiency and durability are critical. But it's not just about the hardware. Artificial intelligence is playing a pivotal role in managing these complex systems. AI algorithms are being used to optimize energy distribution, predict potential failures, and even control autonomous robots that perform maintenance tasks in the harsh environment of space. Imagine a fleet of robotic repair units guided by AI that can detect and fix issues before they escalate, ensuring uninterrupted energy flow back to Earth. Another breakthrough is in the realm of wireless power transmission. Scientists are developing highly precise microwave and laser systems to beam energy from space to the ground with minimal loss. These technologies are still in their early stages, but recent tests have shown promising results, bringing us closer to a future where space-based energy could become a reliable part of our power grid. What's truly exciting is how these innovations are converging. Lightweight materials reduce launch costs, AI enhances operational efficiency, and wireless transmission bridges the gap between space and Earth. Together, they're unlocking the potential of space-based energy systems, making what once seemed like science fiction a tangible reality. These technological leaps aren't just solving technical challenges, they're paving the way for a cleaner, more sustainable energy future. While the promise of space-based energy systems is undeniably exciting, it's crucial to acknowledge the potential risks and ethical dilemmas that could arise alongside their development. Like any groundbreaking technology, the ability to harness energy from space carries with it certain dangers that demand careful consideration. One of the most pressing concerns is the possibility of weaponization. Imagine a scenario where energy beams designed to transmit power to Earth could be redirected or repurposed as weapons. The misuse of such technology could escalate conflicts on a global scale, turning a tool meant for sustainability into a source of destruction. Another significant risk lies in the potential for monopolization by powerful corporations or nations. If a single entity gains control over space-based energy systems, it could create an imbalance of power, leaving entire regions dependent on their terms and pricing. This raises critical questions about equity and access. How do we ensure that the benefits of this technology are distributed fairly, rather than becoming a privilege of the wealthy or influential? The ethical implications here are immense, as unchecked control could deepen existing inequalities rather than bridging them. Environmental concerns also come into play. While space-based energy systems aim to reduce our reliance on fossil fuels, the process of launching and maintaining these systems could have unintended ecological consequences. The buildup of space debris, for instance, poses a long-term threat to both our orbital infrastructure and the broader space environment. Striking a balance between innovation and sustainability will be key to minimizing these risks. To navigate these challenges, global cooperation and robust regulations will be essential. Establishing international agreements to prevent weaponization, enforcing fair access policies, and creating frameworks for sustainable space operations are all steps toward ensuring this technology serves humanity as a whole. By addressing these risks head-on, we can work toward a future where space-based energy systems are not only revolutionary but also responsible. The journey to making space-based energy systems a reality is both exciting and complex, requiring a collaborative effort across multiple fronts. First, we need robust research and development to tackle the technological challenges. This includes advancing solar panel efficiency, developing lightweight materials for space construction, and creating reliable wireless power transmission systems. Without these foundational breakthroughs, the dream of harnessing energy from space remains out of reach. Next, we move into the testing phase. Small-scale prototypes will need to be launched into orbit to demonstrate the feasibility of the technology. These early trials will provide critical data, helping engineers refine designs and address unforeseen issues. Think of it as building a bridge. You wouldn't construct the entire thing without first testing the strength of its materials and design. Once the technology proves viable, the focus shifts to scaling up production and deployment. This is where governments and private companies play a pivotal role. International partnerships could be formed to share costs and resources, while regulatory frameworks would need to be established to ensure safe and sustainable operations in space. Cooperation is key here, as no single entity can tackle this challenge alone. Finally, the last step is large-scale integration into our energy grid. Space-based energy systems wouldn't replace existing sources overnight, but would gradually become a significant part of the global energy mix. This transition would require infrastructure upgrades on Earth, such as advanced receivers and grid systems capable of handling the influx of clean, continuous power. By following this roadmap, research, testing, collaboration, and integration, we can turn the vision of space-based energy into a tangible solution for our planet's energy needs. It's a long-term endeavor, but one with the potential to revolutionize how we power our world. Space-based energy isn't just about solving today's problems, it's about igniting the imaginations of those who will shape the future. Picture a child gazing up at the night sky, their curiosity sparked by the idea that one day the stars could power their world. This vision of space-based energy has the power to inspire a whole new generation of thinkers, innovators, and dreamers. It's more than a technological breakthrough. It's a gateway to STEM fields, encouraging young minds to explore beyond the boundaries of what's currently possible. When students learn about the potential to harvest solar energy from space, they're not just absorbing facts, they're being introduced to a world of possibilities. Projects like space solar farms can become the ultimate classroom, blending physics, engineering, and environmental science into one captivating narrative. These concepts challenge students to think critically, solve complex problems, and dream big. Imagine the excitement of a high schooler designing their own satellite or a college student developing a prototype for energy transmission. These aren't just hypothetical scenarios, they're real opportunities that space-based energy can create. The impact goes beyond individual careers. As more young people are drawn to STEM fields, the collective brainpower working on global challenges grows exponentially. Space-based energy isn't just about generating power, it's about fostering a culture of innovation and collaboration. By tackling the technical and logistical hurdles of this technology, the next generation will develop skills that can be applied to a wide range of industries, from renewable energy to space exploration. And let's not forget the role of representation. When young people see diverse teams working on groundbreaking projects, they're more likely to believe they can be part of that future. Space-based energy has the potential to break down barriers, showing that anyone, regardless of background, can contribute to solving humanity's biggest challenges. It's a powerful reminder that the stars are within reach and the future is theirs to shape. This isn't just about building a sustainable energy system, it's about building a brighter, more inclusive future. The challenges of tomorrow will require bold ideas and innovative solutions. and space-based energy is the perfect catalyst to inspire the thinkers and doers who will make it happen. As we wrap up our journey through the fascinating world of space-based energy systems, it's impossible not to feel a sense of awe and optimism. This isn't just about harnessing the sun's power more efficiently, it's about reimagining humanity's relationship with energy itself. Imagine a world where clean, limitless power flows seamlessly to every corner of the globe, where energy scarcity becomes a relic of the past, and where our planet breathes easier thanks to reduced emissions. That's the future these technologies promise. Of course, the road ahead isn't without its hurdles. Engineering marvels like solar power satellites and wireless energy transmission systems require unprecedented innovation, collaboration, and investment. But consider this, every great leap in human history started as a bold idea. From the first flight to landing on the moon, we've proven time and again that what seems impossible today can become reality tomorrow. Space-based energy is no exception, and here's the most exciting part: this isn't a dream reserved for distant generations. The groundwork is already being laid. Scientists, engineers, and visionaries around the world are pushing the boundaries of what's possible, proving that the stars are within our reach. The question isn't if we'll achieve this, but when. So, as we look to the horizon, let's remember that the future of energy isn't just about technology, it's about us. It's about the choices we make, the risks we're willing to take, and the collective effort it will take to turn this vision into reality. The stars are calling, and the power to answer that call is in our hands. Together, we can light up the world and beyond.